Hello, trig class. In this video, we're going to look at the 8-7 notes product to sum and sum to product formulas. They sound exactly like what they are. We start off with multiplication. We're trying to come up with an equivalent expression that uses addition as the final arithmetic step. And then we do the same thing but in reverse. We start off with addition or subtraction and we show that we can get it to multiplication. So this is a product to sum formula. If you look, we start off with multiplication between trigonometric expressions and we get back to something that has addition and or subtraction as the final arithmetic piece. Technically there's a multiplication by half at the very end, but I could distribute that half through and we'd have subtraction or addition as the last mathematical operation on all those three right hand sides. But notice what we use it for. We have a product of sines and or cosines, and we end up coming up with an expression that has this that will give us the same values but has plus or minus in there in place of multiplication. Where do they come from? Hopefully you can tell on the right hand side they're just the sum and difference formulas again. If we basically took the difference formula for cosine, the difference formula for the sum formula for cosine, and subtracted them, we would get something that looks like that: 2 sine alpha, 2 sine beta, and then we divide away the 2 to get that 1/2. Right? That's all it is. It's just the sums and difference formulas combined together in some way, and that gave us the sines and or cosines multiplied together. So product to sum, sum to product. So there's the product to sum formulas, and again they come straight up from these expressions we saw before. Right? If I subtract them, what happens? These cancel, and I'm left with 2 sine alpha, 2 sine beta. If I add them, these cancel, and I have 2 cosine alpha, cosine beta. So that's literally where these formulas come from. Now, being able to use them, it just means, which ones am I looking at? So I've got a sine times a sine, I've got a sine times a cosine, I've got a cosine times a sine, and that's the three variations. Sine times a sine, cosine times a cosine, sine times a cosine. So sine times sine, I'm using this top formula. I'm subtracting the two angles, first minus the second, adding the two angles. So one of them I'm subtracting, one of them I'm adding. So that's 5 theta minus 3 theta is 2 theta. 5 theta plus 3 theta is 8 theta. So that's what we end up with for part A. All right, for part B, cosine 4 theta, cosine theta. That's the cosine cosine, that's the second one. So subtract the two angles, add the two angles, both inside the cosine function, adding them together. So that's going to be a 3 theta and a 5 theta. And then finally the last one, sine of 2 theta cosine, that's one at each. So we're going to add inside the sine, subtract inside the sine. Right, now remember the sign of negative angle right here. We're going to use the odd property, bring that negative out in front and make it minus. And that will be the last thing we do. Don't leave negative angles inside the sine or cosine. We can use those even and odd properties and fix those. Now sum to product is just reversing the process. We start off with addition or subtraction between trig functions. Sine alpha plus sine beta, sine alpha minus sine beta, cosine alpha, cosine beta, cosine alpha minus cosine beta. And we see that it's a product now. We're multiplying these together. All right, alpha plus beta over 2 is the average of the two angles. Alpha minus beta over 2 is the half the angular difference between two angles. So what I mean by that is, if I have a 20-degree angle and a 40-degree angle, right? This would be a 30-degree angle. It's the average of the two. This would be, take the bigger one, 40, minus the smaller one, 20. That is 20, and divide that by 2. That would be 10. That would be half the angle. Basically, like once I found this, the average, the 30-degree angle, what would I have to add and subtract to get back to my original 2? I'd have to add and subtract this. The 10 degrees to get back to 40, the 10 degrees to get back down to 20. So one of them's the average and one of them's the gap between the average to get back to the originals. All right, but just notice one of them is always, for sines, one of them is always sine and one of them is always cosine, just like it was in the sum and difference formula. When it is cosine alpha, cosine beta, they're both cosines or they're both sines. And notice too, when it is cosine minus cosine, we have this negative out front. Right? When we have minus here, the negation, the difference in the angles is first in the sine, and the sum is over here in cosine. But when it's plus, the addition is in sine, and the negation is, the subtraction is in cosine. Those are little things that separate them that you'll have to remember to be able to use those on the midterm. All right, sine minus sine, that is the second one. So I'm going to have sine in one, cosine for the other one. Sine has the subtraction, cosine has the addition. Right? 6 theta minus 2 theta is 4 theta. 4 theta divided by 2 is 2 theta. And then 6 theta plus 2 theta is 8 theta divided by 2 is 4 theta. So again, we're averaging 4 theta plus 2 theta is 6 theta. 4 theta minus 2 theta is 2 theta. So remember we said it's the average of the two is one of them. And then what do I have to add and subtract from the average to get back to the originals is what we end up with in the other one. All right, cosine plus cosine, that means I'm going to have a cosine times a cosine. And one of them I'm adding, the other I'm subtracting. All right, this one's positive because it was cosine plus cosine. 9 theta divided by 2, I can just leave that. 5 theta divided by 2, I can leave that as well. All right, so that is the sum to products and the products to sum formulas. They all basically come from the sum and difference formulas in some way, shape, or form. So really the sum difference formulas are the ones you got to have down so you can derive the other ones if you need them.